Hello everyone. Sorry, I could not be there to deliver this talk in person, which I really wanted to do, but the whole world wants to travel right now, so there were no visa appointments available for me to make it on time. But I'm grateful to Typotage team for making this virtual presence possible. This form of virtual presence might become better in coming years as we move on to the world of augmented reality. And that is what we are going to talk about today, the world of augmented reality. So let's jump in. No advancement story is complete without the history. The type evolution kind of started with type consumption with Gutenberg Bible transitioning to printed books. Then we went on to 8-bit typography. Then basically reading text on web pages. Further, the type slipped from our desktops to our hands. And with every advancement came new challenges and how we consume typography. So what we did was we adapted to these challenges and designed typefaces to make reading experience better in these mediums. And now we are transitioning to another crucial shift, the era of spatial typography, where text is jumping out of flat screens and we are entering the world of distance reading. Before we move further, I just want to clarify the text in VR, which is virtual reality, is far less challenging than augmented reality. Because in AR, you are competing against natural factors like light, environment, user's attention. Whereas in VR, user is fully immersed. So a lot of these things are under designer's control. Designers don't have to worry if there would be enough contrast between text and the background or text to be legible or not. And we will discuss some of these challenges in detail in coming slides. And another consideration to keep in mind when we talk about typefaces for AR is that I'll be talking about AR headsets and AR glasses, since mobile AR works fine with any typeface designed for user interfaces. And as we know, like there are plenty of options currently available. So headsets are going to be the place where the real challenges occur and the need for where there is a need for typographic intervention from us type designers. So now let's jump on to the main question. Why do we need typefaces for AR? The simple answer is that the new challenges that come with AR headsets. So let's discuss some of these. So I mentioned briefly, but now let's see this in action. I'll just play this video for you. So in AR glasses, we are working on a digital layer over the real world. That means we add text over the real environment. And basically, we could be reading text sitting in front of a blank wall or, or in a really busy cafe with people moving around. So having clear typography that is both readable and legible becomes priority for these glasses to be useful in all kind of scenarios. And talking about home, for us, like home can be the most controlled environment. We can dim the lights to get enough contrast to read text. But as we step out, which is the real case of AR glasses, is not just meant to be just sitting inside your homes and just using that. Basically, that we keep reserved for virtual reality glasses. But as we step out, then we lose that control over the environment. So it can be a bright sunny day or a dark rainy one, but then the text has to work in all these scenarios. And that brings us to the need of letter forms that can aid readability in all kind of scenarios, like either you are just staying indoors or you are walking outdoors. Further, as type designers, our lives revolve around the blacks. And this might not be soothing to hear, but we would be switching to whites in AR headsets. Why? Because in AR headsets, the rendering of text is based on light, and pure black means all the LEDs are off, which lit up to just give an impression of what the text forms are going to be or the letter forms are going to be like. And once these once we do take it to black, then that means all the LEDs are going to be off and the display is going to be transparent, so nothing would be visible. Hence, while designing for AR, whites will be our new best friend. Now that we have started talking about light and displays, let's talk about halation. So the common phenomenon of excess glow around the boundaries of letter forms. So what that does is deformation of letter shapes, and that can result in legibility issues because it might fill up certain kind of apertures, and basically a C with excess glow uh, can be misrecognized or misread as O. So these are certain challenges which come with halation, and it becomes quite prominent when the display brightness is increased to the highest level, and that is something which is quite necessary when we are talking about usage of AR glasses outdoors. And for the vibrating text, this is the biggest technological issue that we are facing. So when the user moves around, the text in these displays has to continuously render at different places. Since the refresh rate, or to simply put it, the speed with which the text has to render at multiple places as the user's head is moving around, uh, our perception of that rendering is quite slow, and our perception tends to be much more faster. So basically we can so it makes us perceive those vibration in text, or those jerky transitions when the head is moving around, and because of this basically the readability suffers a lot. So if the strokes are too thin, then they will vibrate and become illegible. And just to illustrate that, with this example, just have a look at this video. Focus on the text and then how it's moving around, and then basically, if you're reading this text, how good of an experience can it be? That is where like having good letter forms, or like having something designed to tackle this challenge, can be really crucial to make the reading experience better. So further, now I want to welcome you to the world of infinite possibilities and scenarios to design for. And here, what I mean by that is, in AR, we would be designing for a range of different usage where text can be up close to us or it can be several meters away. And there will be new variables to keep in mind, like the reader is moving, the text is moving, text is being viewed at an angle, and so on. There are multiple challenges that we are going to face. And another big one is selecting right font weights will also be a challenge because of rendering issues. So high contrast is required against background in AR, and light and extra bold weights of our typefaces tend to be really problematic because lightweight typefaces tend to vibrate and not and sometimes not render fully. The full letter form can't render because of like pixel distortion, and then not finding like enough resolution to maybe render those curves. And when we talk about bold weights can get distorted by excess glow, which we were talking about earlier, and sometimes it just fills up the like counters. And so what I'm speculating here is that there might be a change in weight distribution while we are designing for AR headsets. So what I mean by that is there can be increase in stem widths of a regular weight that we design for, to compensate for these busy backgrounds. And this is the approach that I took while designing my typeface. So basically, weights like light or extra bold might see lowest adoption rates and usage because of legibility issues that I have been mentioning. So now that we have dabbled through few challenges in AR, the main question that comes up is how can we make the reading experience better? And my answer to that question was designing better typefaces for AR. Since there was no information available on this topic anywhere when I started working on this. So I started off by scouring through industrial research as old as 1960s when the whole idea of AR and VR started shaping up. And then basically studying type history and research to draw parallels that can help me in solving these challenges that I discovered. And that is how the AR1 or Arone type family came into existence, a type family designed specifically for AR headsets. Here you can see a comparison of Arone to existing typeface in low resolution. So the low resolution test kind of gives a good impression of the challenges, and then basically it amplifies all the challenges that we face while working on making the reading experience better in AR headsets. And then basically it just since it works on amplifying and showing those extremes, it becomes a good testing ground to see the feasibility, and then whatever the design that we are doing, is it going to work in multiple scenarios or not. So my approach to solve the issues was to learn from past, since we have seen several technological shifts and typography has evolved along with them. And it helped me a lot to decode various aspects and use those learnings to design Aaron. And so I would like to share some of these and what I mean by learn from past and design for future. So one key feature from that approach were light traps to reduce the effect of halation that we talked about at the intersections. And a direct parallel was drawn from the ink traps that are quite I think popular that we know about. And at the joint of strokes, the excess light distorts the shapes of the letter forms and causes misrecognition of letters. Hence, introducing these light traps to reduce that excess glow helped me in terms of improving the reading experience to a good level. And basically, it worked out pretty well when I was testing. Further, this one piece of advice from Gerard Unger changed my perspective on how I was thinking about some of these challenges and how to solve them. So, and this is what came out of it. Basically, I leveraged the shortcoming of technology to do the job for me, and I tested various cuts to obtain the optimum shape after rendering on AR display. So the actual letter shape is what you see on the left, and on the right you can see how it actually renders, and basically you can see more like elegant curves as compared to the actual shape, which is quite funky with those cuts. And because of halation, so what it does is that excess glow fills up those amplified cuts, and then at the intersections, and these that filling of gaps because of excess halation just does the job, and then basically gives a smooth appearance, a smooth curve, and which retains the shape which I wanted it to appear when the user is reading it. And this approach is again tied to history and the Duggin's M formula and the marionette formula. That was based on Duggin's experience of carving marionette faces, where he observed that marionette faces carved in flat and more angular manner appear to be more expressive when seen from a distance, which work perfect because viewers of puppet shows see marionettes from further away distance. And he used this approach to design typefaces for newspapers, which was quite successful. And basically, I took inspiration from there and then used that approach to design Aaron. Further, let's talk about scalability. So when we are designing typefaces, there can be two approaches. Either we design with scalability in mind, or we ignore the fact that tech will be evolving and the needs will change with time. And go on with this mindset that we'll see to it or we'll cater to those needs when the time comes. And the tech world is quite known for this bias towards the top user base section with all new flashy tech that is up to date, and ignoring the needs of like lower spectrum of users who might not have the best tech available. And here I just want to ask a simple question. Isn't it a case of denying a good user experience just based on the cost of devices or like what you can afford? But as a type designer, we can advocate and facilitate the better reading experience by designing typefaces with scalability in mind. And as an advantage, it can prolong the usage of our typefaces and give us an opportunity to see our work being used in long range of devices and long range of scenarios as well. And that is what Arone like is designed for. It has duplex weights which can be used in high and low resolution devices. So using some queries, if the device detects lower resolution, then the text is rendered in microweights, which is optimized for lower resolution headsets. Or else, like if it is the normal like high resolution headset, then basically the standard version is loaded. So because of this duplexing, there is no change in width of the text, and text remains in place, and the experienced designers don't have to design two separate versions for high resolution headsets and or low resolution headsets. So as a result, the user gets a better user experience, no matter which headset they are using. And since we are talking about 3D space, it is a usual occurrence that to see text from a perspective, because you might be walking on a road and there might be a signage, a digital signage, or you're walking around maybe a monument which has like AR based labels which show you certain like historical information around them. So here you would be reading text at a perspective or from different angles. And to avoid any legibility issues, so ample spacing was my answer to make this like to reduce that angular distortion and then make perspective reading much more better experience. And that makes sure also makes sure that the letters don't overlap when we see them from an angle. Similarly, other features that have been used in Arone are strong stroke endings to reduce any rounding by halation. And so what I mean by that is at the stroke end, when halation happens. So when we talk about light, so light always try to take the shortest path. And then because of that, what happens is at the endings tend to look rounded from a distance. And then if that sometimes that stroke, if it is maybe 10 units, then in perception it might just appear in rendering as just like 8 or 9 units, and then the ends are quite rounded. So the uh, if the endings are quite reinforced, then basically that rendering happens at the level, and then you even if there is a rounding happening, then you add extra weight to or like flares to the endings, and then basically what it does is like rounding happens, but rounding at the end uh, goes on to forming the natural stroke. So in this case, again, you retain the main shape of the letter, which aids legibility. And sometimes because of this rounding, what happens is certain letters like L or I tend like because rounding happens, so they tend to float over the baseline. And to avoid basically this also works a lot better to avoid any misrecognition of letters. And Another important the key feature that I design for Arone is that Arone has been designed keeping in mind complex scripts to make it scalable not just on devices but also across regions. So what I have covered so far is just an introductory layer, and if you're interested in knowing more about these aspects and then more details, then the information is available on my website. Please use this link, or you can Google XR typography guidelines and you'll find all this information. I hope this serves as a conversation starter for you to start thinking about this new medium. If you have any questions, then please feel free to ask them. Thanks a lot.